All right. So I wanted to finish off skill 5 with just a couple extra examples, sort of one here from the book examples, and then I think I'm going to do 2 from the exercises, assuming we have time. I'll maybe try to talk through them sort of medium fast. So other volume things we can do in skill number 2, when we were talking about perimeters and areas, initially we sort of had our original sort of polygon formulas. They were good, but only sort of so many versions of things to do there, right? Sort of just find the area of this, find the area of that. What was more interesting and that I liked, hopefully you did too, were more the compound shapes. So you're looking at sort of combinations of different polygons sort of stitched together and trying to find the sort of areas and perimeters of all of those. So you could in theory do versions of that with volumes. We're not necessarily going to get super deep into this, right? You're not talking about tons and tons of sort of compound shapes that we're doing the volumes of. In theory, the same kind of principles apply. But one example here would be if you think of like a socket wrench, right? And this is sort of a crude drawing. What would be the sort of top portion of a socket, right? So you have what would be sort of the cylinder size to different bolts. And then you have the sort of connector piece, right, which is this sort of rectangular prism, right, this sort of rectangular box that's been sort of cut out. So this would be sort of where the wrench would pop in there, right? You can attach these sort of different shaped sockets onto your wrench to be able to sort of screw and unscrew different size bolts. So one thing we could do, a volume problem that we could do, is we could sort of find the volume of this socket. So this is a cylinder with a radius of 14 millimeters and a height of 18 millimeters. So that is right, our kind of radius is here, our height value is here. What did we just say? The height is 18. My radius is 14. And it has what we're calling a cubic void, which is sort of an incredible phrase, a cubic void. So what this means is a hole that's shaped like a cube. I don't think we sort of said this directly, but a cube, of course, right, is a three-dimensional square, right, meaning sort of a rectangular prism where the length, the width, and the height are all the same value. So a cubic void in the top, right, which is sort of where the wrench attaches, with a 10 millimeter side. So that is all of the lengths on this are 10 millimeters. So the length, the width, but then also what would be sort of the depth here, right? Sort of what we're going to think of as, I guess, the height. I hope that's coming through okay. Yeah, it's visible enough. So what's the concept here? So I want to find the volume of this thing, this sort of socket. And all we're going to do is the sort of pretty basic setup of find the volume of the cylinder, right? What would sort of be the volume of this whole cylinder? And we're just going to subtract away the volume of the void, the cubic void, which is, I think, now my favorite thing that I've ever heard, a cubic void. So the total volume here is just going to be the volume of the cylinder minus the volume of the cube. No problem. My cylinder volume, pi r squared, right? My circle area times the height. The volume of the cube here would be, says s cubed. This is, right, length times width times height, right? If all of those are the same, then you're going to get essentially the value cubed. Lo and behold, right? A cube, right? Literally a cubic value, right? These things are related. So just sub in these numbers: radius 14, bam. Height of the cylinder 18, bam. Side length, the length, the width, and the height of the cubic void is 10, bam. So pi times 14 squared times 18 is going to be 1184 minus 10 cubed. 10 times 10 times 10 is 1,000. All my units here are in sync, right? Because this is a volume minus another volume. So my units here are good to go. This is going to get us 10,084 cubic millimeters, which the book is telling us is about 10 centimeters, centimeters cubed. There is a conversion here. There are 10 millimeters for every centimeter, but those conversions get sort of multiplied and expanded as you're talking about areas and then volumes. So if there are 10 millimeters per centimeter, there would be 10 times 10, which is 100 millimeters, square millimeters for every 1 squared centimeter, and then there would be 10 times 10 times 10, 1,000 cubic millimeters for every 1 cubic centimeter. So we're going to end up with something like this. So that's our socket, right? If we ever had to sort of find the volume of a socket, that's the kind of thing we could do. Moving on. Whoops, almost lost that sheet. Number 14 here in the exercises is sort of a fuel tank example where we have some unit conversions to deal with. So if you assume your fuel tank is roughly a rectangular prism, right? So that is sort of 3D rectangle with a width of 7 inches, a length of 18 inches, and a height of 24 inches. So assume that's your fuel tank. Obviously, fuel tanks are not necessarily rectangles, but we'll sort of assume they are for the sake of argument, for this problem at least. If you have 2.3 gallons of gas, so keeping in mind, of course, that we just talked about inches and now we're talking about gallons, so we need a connection there. If we have 2.3 gallons of gas left, how many gallons will you need to add to fill the tank? And we have a little conversion here. Let me sort of write some of this stuff down for us. Is that all visible? Roughly. Skill number 5, question number 14. So we said width is 7 inches. We said my length, 18 inches. Height, 24 inches, right? So I can get a volume there pretty quickly. It's just that my units will be inches cubed. I have 2.3 gallons of gas. How much do I need to fill the tank? Question mark. With this sort of unit conversion, that 1 cubic inch in volume is going to be 0.004329 gallons. So that unit conversion is really going to be key to this problem. So it makes this all work, right? So let's just sort of quickly find the volume of this tank. So this is just going to be a length times width times height, right? So this is a rectangular tank. Something kind of like this. We've got a certain amount of kind of gas in here, right? That just looks like a bunch of mush now. So this is 18 by 7 by 24. Crunch, crunch, crunch. Times 7 times 24. So 3,024 cubic inches, right? So that's the volume of the tank. And so what I have is a certain amount of liquid in there, but it's in gallons. So what I need is I need the volume in gallons, right? Perfect. I know every 1 cubic inch is this 0.004329 in terms of gallons. So all I'm going to do is I'm going to take 3,024 cubic inches over 1 times my conversion rate, which is 1 cubic inch for every 0.004329 gallons. So this is just a quick multiplication, right? 2024, so times 0.004329, so 13.09, I guess we'll call that 13.1 gallons. Right, the units here are canceling out just the way you would want, inches cubed to inches cubed, so 13.1 gallons, so that's total. So then the question here, the extra sort of question I've faced is, I have 2.3 gallons. Got 2.3 gallons. So I need the total amount minus the 2.3 I've already got. So we'll call this 13.1 minus 2.3. Probably could have done that in my head. 10.8 gallons. So that's the gas that I need to fill this tank all the way up. Pretty good. Let's do one last question. We're going to need just a little more time. All right, we're going into video number 4. I didn't want to have to do it, but we're going to do it. All right, so we'll see you in the last video. Video number 4, one last good example.